let's solve the today's LeetCode challenge, which is design graph with the shortest path calculator. So here in this problem we have to implement this design class where we are given with n, the number of nodes and the edges in that graph. So the one edge will represent the source node, destination node, and the cost to reach from that source to destination. So if you know the basic concept of graph, you would know that we can store the graph in the form of adjacency list. So if in case you don't know the basic concept of graph, or you having facing difficulty or to understand this problem, or maybe algorithm that we are going to use, which is Dijkstra algorithm, so comment down below. I will just prepare a separate video for that. So now from the given input we will create our adjacency list, and if we have to perform the add edge operation, so upon calling of every add edge operation we are going to add one edge to our adjacency list, and upon calling the shortest path operation we will just perform the Dijkstra algorithm over our adjacency list using source as a node 1 and destination at node 2, and we'll just return the minimum cost from these two nodes. Okay, let's try to have a look on this example. So we are given with a directed weighted graph from 0 to n minus 1, and edges in the form of this from node to node and the cost. So let's have a look on this example. In this graph, operation is called with these values, 4 node, and these are the edges from 0 to 2, 0 to 2 we have 5, 8, like this. And after that one operation is called which is shortest path. So we have to now find the shortest path from node 3 to 2. So if we have to just do the iteration from source to destination, whether there is a path or node, or maybe finding all the paths, in that case we can just do the direct DFS or maybe BFS, like reading checking for all the nodes. But here uh, we cannot directly straight away do the graph traversal, because we have to find the minimum cost. So in that case we can go greedy, and at every moment we will just consider that node which is going to be beneficial for us. So in that case we will minimize our cost. So in that case we can just have our cost array. uh, in this cost array we will just store the value of the cost to reach to a specific destination. So the cost of this index will specify the cost to reach 3 from our source. Okay, so let's have a look on the adjacency list of this given input. So from 0 there is one node, from 1 there is one node, and from 3 there is one node. Sorry, from 0 it was two nodes. So from 0, 0 is connected to 1 and 2 with weight 2 and 5. 1 is connected to 2 with a weight of 1. 2 is not connected to any other edge or maybe any other node. 3 is connected to 0 with weight 3. So this adjacency list we can store in form like a list of integer array. Integer array, or maybe so you can take pair here, because we have to store two values, the node and the cost. Okay, so we will implement the Dijkstra algorithm using priority queue, because at every step we will just have to get the node which is going to give us the minimum cost. So let's try to write the code for that. If you don't know the basic understanding of Dijkstra algorithm, you can just let me know. I will just prepare try to prepare another video and just help you understand that as well. Okay, let's try writing the code for that. Here, firstly, we'll just have to form our adjacency list. So for our adjacency list, we are just going to have a list of integer array and then calling it adjacency. And in the graph initialization, we can initialize this adjacency list, new array list, and for every node, we are just going to add the empty array list for now. For I equal to 0, I less than n, I plus plus, and we'll just add edge for add a neighbor list for all the node, new array list. Okay, so we have now blank adjacency list for each nodes, and now we are also given an array of edges. So instead of adding these edges, we can utilize our add edge operation. So that is also going to be called from outside. We will also take privilege of calling that add edge operation to add our edge. Every edge is an integer array, so edges. So now we will call add edge operation over every edge. So how do we call an edge? So edge is in the form like from to with the cost. So we'll just add in our adjacency list. We will firstly get the get the list associated from this our source, adjacency dot get add edge of 0. Now in its neighbors, we'll just add 2 along with its cost. So in the edge 0, we will add new integer array with the values 2 node, which is edge 1, and the cost, which is edge 2. Okay, now our edge function is also prepared. We now have the adjacency list, and we have initialized this adjacency list, and now we just have to call the Dijkstra algorithm over that. In the Dijkstra algorithm, firstly we'll just have to maintain a priority queue of integer array pq new priority queue. And in our priority queue, what we are going to store is, we have to just minimize the cost. So we are going to store the values like the cost and the node where this cost will lead to. So if we get an element from this priority queue, we are going to get a node get a node which is closest to our current node, because we are like going to store it on the basis of cost. So like we need ordering on the basis of first index comparator dot comparing int, which is our first element, or maybe we can pass the lambda here. If a is our integer array, then a0 will be our uh, comparing criteria. Now we just also take the n adjacency dot size Apart from that, we just also have to take take the cost in the form of an array, uh, cost for node. So in this array, we are just going to store the minimum cost to reach to that specific index from our source. This should be array is equal to new int of size n. Okay, now we have our priority queue, we have our integer array for cost, and now what we'll do is we'll just add the starting point in our priority queue and do the traversal from that and start the traversal from there. So pq dot offer new int, what is the cost to reach to the source from source, which is that is 0. The cost to reach to 3 from 3 is 0, that is understood. And for node 3, also here you can store the cost as well, cost for node, which is node 1. Here we will also use node 1, which is our starting node, is equal to 0. Minimum cost to reach to our starting node is 0, and we will also add that in our priority queue. And now we will do the traversal until it is empty. While the priority queue is not empty, perform this. Okay, now just firstly just get the current element, integer current element, priority queue dot poll. We got the current element, and now we'll just have to uh, get the cost and node for that. Int, let's say it is current cost is current dot 0, or maybe current node is equal to current dot 1. So our current node is 3 and the total cost so far is 0. So at every step we can just add our edge cases, whether the current node is equal to node 2. If we are at our destination node, what we are going to do is we will just return the current cost in that case. That would be the cost, minimum cost of that path from node 1 to node 2. Or in other case, if the current cost is greater than the cost for node and the current node. So let's say if at any moment we'll get a we are getting a cost which is bigger than our current cost. So let's say we are at 2, and for 2 it was like let's say if we are getting getting on second element with the current cost as 4, and earlier it was stored in the current cost node, sorry, in the current cost node array is was 2. So in that case, like we are just going to continue, we don't have to do this, go into this iteration. Okay, now what we will do is we will just iterate on every neighbor of the current node. For integer array neighbor dot get current node integer, let's say neighbor node is equal to, so in our adjacency list we were storing in the form of like this neighbor and the cost to reach to that neighbor. So our neighbor node is neighbor 0 and neighbor cost is neighbor 1. So let's say we are going to this neighbor. So our new cost would be current cost plus neighbor cost. If our new cost is less than if our new cost is less than the cost we have already there. So if in case we have found the new smaller cost, we will just update that cost in our cost for node array. Cost for node neighbor node, in that case new cost. Okay, if that is less than the previously calculated cost, we will update the previously calculated cost. Okay, apart from that, we will just offer the value in the priority queue. Priority queue dot offer new integer array, which is new cost and the neighbor node. Okay, so firstly we were having 3 in our priority queue, and now from 3 like we have inserted 2 sorry 0 with the cost 3. So now from 3 the cost to reach to 0 is now 0 plus 3, which is 3. It is less than infinity, so we will keep on updating this cost array, and ultimately like we will have our solution. Okay, and if any case like we are not able to get to our destination node, which is node 2, in that case we will just directly return -1. Okay, we prepared the adjacency and then added the node, mm, wrote the algorithm for Dijkstra algorithm. So Dijkstra algorithm, we will use a priority queue on the basis of cost. While the priority queue is not empty, we will perform this operation current cost and current node, and then we will check for all the neighbors of current node. Okay, adjacency dot get current node should be in the bracket. This was some syntax error. Okay, all the neighbors of current node, and then we will just calculate the cost for the current node and we will keep adding it in our queue. Okay, let's try to submit it. Let's try to submit it as well. Okay, it is accepted solution. So yeah, like if you are not able to understand the Dijkstra algorithm, try to have a look over some tutorials, or maybe like I'll just also prepare some video for that. And meanwhile, I'm attaching the code in the description below. You can have a look and make a dry run over some given test cases. Okay, thank you guys.